as I went back through, of course, the plan questions.
Now, real quick, can I interject something? There's some out of that first line item, that 8 out of 12 that you got, right? So
Right.
that's a high number of questions to miss out of that section, to be honest, because you're talking about basically Ohm's Law stuff,
Right.
print questions, and definition questions, which are 3 categories that most guys do pretty strongly. And I'm not saying that this is enough.
That's what I thought. Now, I can tell you there was some questions that I got to that I couldn't figure out where to find it in the book. I got to some and it was like, can you get that phone?
Hey, at least it's not a gay ringtone or something like that. I mean, you gotta catch your blessings. I'd give you hell if it was.
Yeah, and I'm not joking. There was some, and that's the ones I tagged towards the end of the test, because I had when I ran through, I'd already tagged all my math questions, and then I had to come back and just tag a couple of the ones that I kept looking for and I could not find. And I'm sure they go to that area right there, but
okay. But you were smart and you just kind of looked at it a little bit, and if you couldn't find it or get traction on it, you left
right.
it.
No, I passed it. I figure if I spend more than 3 minutes in the book, then I tag it and try to come back later and go to the next one.
That's a smart strategy. All right. So you said there's about 20 questions, and so do you remember any of those questions? Were they kind of definition questions, or were they like Ohm's Law, where they had solar PV panels and giving you a bunch of ratings and stuff like that, or were they just strictly code questions?
I don't know if I get this because I've been looking at all the practice stuff, but I want to say there was one similar to the one that you have in your book, because I looked at it today and I was like, damn, man. I mean, I think it was that one.
Which one?
It's not like our simple ones. It's like it didn't give any numbers. Where did I see that?
What kind of question is it?
Well, I thought here it is right here. It's in your main our study book on 41. I want to say there was a resistor setup like that, or a series.
It's a study book on page 41. You talking about the crash course book?
Crash course book.
Can I see it? Or they drew it out like that?
I want to say that. I want to say I remember something like that, and I just had to guess because it threw me for a loop. I didn't even know what I was looking for.
Okay. So was it a series parallel, or was it series or parallel, one of the two? The combo?
I don't remember. Okay. It might have been a series parallel or something like that.
So that piece right there, plus the fact that one of the things in that category that would be about 4 questions is Ohm's Law. So it's possible that you missed 2 or 3 of the Ohm's Law, just not getting traction on them.
Right.
And then the other 1 or 2 might have just been a rare, kind of an oddball worded definition question or something. But that makes me feel better. So if you want, we can cover that real fast. But I mean, it's pick your poison. We can do that and motors, and that's 2 groups that we could consolidate on.
Right.
But before we do that, let me let you finish going through your questions there, because I didn't mean to cut you off.
No, that's no problem. Yeah, just to hit some of these key ones that I know I don't know if I had a problem with them or what. You don't still have a copy of the plans, right?
Well,
because I know one of the questions
I would never have a set of print plans. That's just.
I don't know. I mean that example one that we kind of went over.
Example ones I do have, yes.
Okay. I remember a question that stated something about H1, where the panel H1 was receiving its power from. And I know I answered MSB off the top.
Then you stop it. That hurts.
Does that sound familiar?
Well, yes. One of those panels does have some lighting contactors going through it. An H13, for example, is the corridor lighting, I know for a fact. So if those things are fed through a lighting contactor, but there's no, that question I think I've heard in the past, and they're asking you which one Or is it fed from? If it's fed
What?
from, it's fed from the lighting contactors. If it's asks you where it draws its power from, then the power would be, you know, MSB or whatever the feeder schedule says. Coming.
Okay. Then
All of your high voltage panels come off that MSB. There's 3.
right.
Yeah, and then but if that one in particular, I think is all lighting, and it does go through a set of contactor cabinets.
Okay. And then of course the west wall, that one was on there.
They did give you. They asked you for like a cardinal direction on the west side wall packs or something like that.
It said the outside light or something about the outside luminaires or lighting on the west wall are fed from something.
Okay. It's been a while since I've heard that one, and I didn't know. But did you turn the prints to make sure the arrow is pointed up instead of?
Yes.
Okay.
I made sure on that. I don't know if I went to the right. I think I went to the right panel. I don't think I did 2. What would, let's see.
There's about 4, 4, and 4 is the breakdown. So there's the, you know, it could have been you missed 1 out of each.
I might have missed 1 on that one too. Yeah.
Did you have a question asking about how many lights there were on H13 or?
Yes. Or no. Was it? Yeah. The answer I found was 35.
Yes, I think
Okay,
that's
so that one was there. LC1 or was it L1C or?
yeah, L1C for the panel that's in room 110.
That was what were my other questions?
That's all. That's it for the prints. That's more than you'd have in.
Then that was it.
How many lights on H13 and then the panel in room 10. Okay, thank you.
Right.
All right. So, and then what about the questions? Let's go back to the ones that you said you couldn't get any traction on. And I'm not trying to beat a dead horse. If you don't, sometimes it's so vague that you don't really understand what they even are asking you. So it's kind of hard to remember them if you don't understand the question at all. But what do you have that you can recall that you just searched for and you just couldn't find that I could maybe help?
I really can't. I mean, I think I basically shut down after the test because I cannot remember which ones those questions were.
Okay.
And I'm just saying there was probably a good 4 to 5 that where I knew were definitions or I could find the answer located somewhere in the book like the rest, but I just could not find where to go and get the answer.
Okay. That's fair. I mean, that's probably exactly the way most people come back from the test. I mean, after a while, you just kind of get burned out on it anyway. But sometimes questions you just don't. If you don't understand what they're even asking you, then it's kind of you don't have anything to.
It might not be that I didn't understand it. It might not just. I was looking. I know I looked some things up. I'm trying to remember the keywords that I was trying to find.
Up to you. I mean, if you remember between now, just in the
I can tell you one. That it was a basic question that talked about a hazard towards the end of the question, and the 4 choices were overload, overcurrent, frequency, and I guess harmonics. Maybe. Does that sound familiar?
Yeah. So would it have anything about nonlinear loads or counting?
Something. Well, however the question was stated, it was written, and then towards the end of the deal, it said either could cause a hazard. I don't remember the key phrase on the last of the question, but it was talking about it had hazard in the question.
Okay.
That's one of the last words, and then the 4 choices were overload, overcurrent, frequency, and harmonics.
Okay, so the
I think harmonics, maybe.
Oh, harmonics is probably what it was. The frequency is one I think maybe might not be. That might be.
But see, I tried to look it up in the book, and that's one that I went to overload. I went to overcurrent. I eliminated them. I'm pretty sure, but I couldn't find the key answer. I couldn't find the actual answer written in the book.
Well, harmonics cause hazard in electrical circuits because when you're talking about the especially the grounding conductor where you've got a multi-wire branch circuit where you've got a neutral and you've got 2 phases that are on sharing that same conductor. So if you have any harmonic distortion, the triplins, the 3rd, 5th, or 7th harmonics, then that feedback, changes the sine wave, and there's no cancellation effect anymore. So the hazard there is that you have an overload on the, it's kind of an overcurrent situation on the neutral conductor.
Is there any way that they could have stated that in a motor?
It's possible because motors are they're an inductive type load, so they're not linear like we tend to think of like a space heater with just
Right.
heating elements. That's linear because it just burns up and that's it. But motors with the windings, the magnetic fields that they put out, you know, it's an inductive load, so they do cause harmonic distortions. Now the frequency. Now frequency, and that makes sense because each one of those things has something to do with motors.
Well, that's why I'm thinking that. And now that I'm thinking back, I think motor was in the keyword.
All right.
Or maybe it said burn up, or what could call it hazard to somehow.
If they're asking you what prevents the hazard from occurring, you know, which device or what protects or what component you're protecting against, you know, each one of those is an item that's
Right.
to itself. So if they were asking you which one causes the hazard, then it would be probably harmonic, or, you know, a frequency is what we use to change or control the speed of an AC
Right.
motor. So, I mean, it's
Changing the frequency would basically be like the VFDs and stuff like that.
Exactly right. That's exactly right. Yep. Mm-hmm.
Okay.
So the devil in the detail in the way that was worded, I would imagine.
Right. And it was just that I couldn't find the keywords, and it wasn't I guess if I went to the motor section, I probably could have found it.
Yeah, I don't know that you'd necessarily be in the motors though, because this is something that might be in 240. You know, because we're talking about overcurrent devices. So, so it could be there. It could be, you know, it could be in Article 300 for all I know. I don't know that I've ever seen. The only time I've seen any harmonic stuff listed is in 310.15b.
I think I read that today.
Yeah. So if you, but that's a neutral load calculation on linear loads. But at any rate, so yeah.
Okay. Let's see. The only other ones. Let's see. I think I wrote some on the back of these.
You promised me one question that I've been dying to hear. I think it was you.
Oh, what was it?
Wasn't it you?
I don't know.
Something about a branch circuit in a closet?
Branch circuit in a closet?
Arc fault protected, or when it can't be or can be? Or
Man, I tell you what, I don't know if I told you about that, but that was on there.
Okay. What do you remember about the details of
it? Was something.
Let me.
I remember that question.
20-amp branch circuit. It runs through a closet in a dwelling, and they're asking you when you not be permitted or required to be arc fault protected, and then they give you 4 choices that are when it's in MC cable or EMT cable or something like that. Does that sound right?
No, yes, that sounds very familiar because I remember the closet question, and I was like, how in the hell do I find this?
Yeah.
Because I don't remember seeing anything in the closets as I looked through everything.
Yeah.
So far.
So the component to that question is the arc fault, rule, and then the second part of it is it's a fire alarm circuit. So
that's what it was. It was under the fire alarm.
760.41.
Yeah, let me look real quick because I do remember that, and I think it had fire alarm written in it.
Okay, yeah. If it's feeding the fire alarm circuit, then it is not.
That's what the question was. It was a fire alarm, and it talked about a receptacle or running through somehow through the closet. Yes, you're very. Yeah, I mean that's it. I just don't remember. I couldn't tell you exactly how it went.
Well, let me ask you this: were at least 2 of the questions metal covered conduits or raceways or factory assembled cables like MC and EMT or AC? Armor cable.
I'm pretty sure there was a. I'm not sure if it was PVC or if it was EMT. I think was one of the answers. I mean, one of the questions. I mean, one of the answers.
EMT was
right, and then could they have said PVC? Maybe.
Possibly EMT or something, or some sort of a non-metallic conduit would be probably. I mean, you could have seal tied or.
Right.
Let's see.
And then I think it might have been MC. I'm pretty sure I probably got that one wrong, so I don't remember the answers.
Let me point you to something real quick, and then read them, and then that way at least you'll know what the 2 sections that I think it's going to answer it, and then you can maybe if you see that question again, you'll be forewarned. So the first is going to be 210.12, and it's in the exceptions. It's on the right-hand column, about middle of way down on the page. Let me go get my code book real quick. I'll be right back.
Glasses. Let's go. You have it.
All right.
I even had that one highlighted as one of my.
I'm sorry. What'd you say?
I was gonna say I even had that one highlighted as one of my different color highlights.
Okay.
Did I miss?
So 210. What page number do you have there?
56.
Page 56. Thanks, sir. Right there in the exceptions on the right-hand column, it tells you that where an individual branch circuit to a fire alarm system is installed in accordance with 760.41b or 121b is in RMC, IMC, EMT, or steel sheath cable, AC or MC. So what I've heard from most guys is that they'll try to use one of those answers that has one of those conduits listed as their answer, because
Right.
they see it in the exceptions, and that's the logical place for them to go to is right here in 210.12. But the problem that I foresee with that is that almost every one of the people that have seen that question say that two of the answers both fall under this exception. So in other words, one of them was MC and one of them was EMT or something. Both
Right.
there. And if that's the case, that automatically tells you that it's a suspect answer because you can't have two of them that are correct, right? So
Right.
that eliminates those from even being an issue. And the bottom line is that if it's in italics, you cannot reference it unless it's specifically given to you as an instruction.
So do you think there's a trick to the question?
Well, what it is that the 760.41b is what tells you that you're not supposed to run those on either ground fault or an arc fault protected circuit. So that's really I think what the article that controls it is. So when it's run as a fire alarm circuit under the rules of 760.41 or .121, then it would not be required. In fact, it would be required not to be on an arc fault or ground fault circuit.
Okay. Okay.
So whatever answer sounds like it's talking about when it's run as a fire alarm circuit, it can't serve any other loads, or if there's any kind of wording like that, then that's definitely going to be it. But
Right.
I think I've seen one of them just say where it's run under 760 whatever, and then so that maybe it's part of the answer block as well. I'm not sure.
Okay. Yeah, and I tell you one that really ate me up, and I know we went over it, was the HPD.
Okay.
Oh my gosh, I went back to my wire tables and I was like, damn it, you got to be here.
Did you find it?
Finally, I mean, I actually found it later by skimming through something, and then I went back and I was like, there it is, and I had it highlighted just like we did. Oh my gosh.
There's three tables in your code book that all have to do with wire. There's the stuff that's in 310.104, and then there's the flexible cords, and there's fixture cables and stuff in 402. So,
well, it had me so jacked up. I went to the back of the book and started looking at those, and I was like, it's not back here. So I went back to the front, and as I was skimming through, it finally stuck out to me, and I saw it at the bottom of the page, and I was like, because that was the only one I had highlighted. I was like, there.
Dumb luck's not a bad thing as long as you get some of it. I mean, that's,
Oh, yeah. No, exactly. I wasn't sure about, I believe there was a Y transformer.
Okay.
I think that one jacked me up.
What, do you remember what they were asking? Were you sizing a breaker or sizing conductor, or just asking for the output or input or amps or KVA or anything?
No, and I know that's so broad that it could go in any different direction.
So, was it but it wasn't a calculation question, it was just a code question?
No, I'm pretty sure it was a calculation question, but I don't remember what calculation it was.
Okay.
I just know I think I might have struggled on that one.
Transformer questions are actually pretty easy once you get the basics of them, but they're not, I mean, they're easy to get confused because they can throw in a lot of big words that'll just get your head spinning. You'll feel like you're in some kind of a rocket scientist course or something, but it's really, it boils down to Ohm's Law is really what it is. But,
well, it kind of started tricking me or into thinking that I needed to apply the 1.73 rule and all kinds of different other math. And I don't know. I probably figured up a math question that doesn't even exist.
Well, did you get one of the answers that matched up?
I think so.
Well,
I can't say that it was right, but I think I did at least get an answer that was.
that would be one of those questions that might fall under the feeder, depending on what they were asking or how they're asking you. But it could have fallen under either that third line item, or it could have possibly fallen under the second line item, or conceivably it would fall under electrical equipment and devices, which is probably unlikely. But that's really one of the code questions there. So. You missed 6 questions out of that block of those 2 that are the line 2 and line 3. So 7 questions. It could have been one of those. I mean, it could have been asking. Now, transformer feeders are calculated under Article 215, and those are not continuous duty load considerations. Those are simultaneous duty loads. So those are a little weird math and a little kind of a different slant, but it's in 215 under feeders, 215.6 or 7, I think. Let me see here. And somebody told me that they had some that were actually specifically listing, what panels that these transformers were feeding and what types of loads they were. And when you get all that kind of detail, that's what we based a feeder calculation off on under 215. It's dot 2B 1 and 2, but feeder supply and transformers and utilization equipment. But the last I'm on page 64.
Right.
In the right hand column toward the bottom under section 2 where it says feeder supply and transformers utilization equipment.
Yeah.
And the math of it's that last 2 lines there. So it's 125% of the design potential load of the utilization equipment that will be operated simultaneously. So it really boils down to whether or not it'll be on at the same time or not. And
would they state that?
Well, I mean, depending on if they gave you the kind of question I'm talking about, where they gave you a transformer and a panel and what all the load types were that the panels were what kind of loads they were. Now make sure that you get the sum of the nameplate rating of the transformers and 125% of whatever simultaneously running. So it's those 2 numbers there. So if they gave you a Y transformer and they gave you the primary voltage and the ampacity of it or something, then you'd have to calculate out the nameplate rating of it, which would be the kVA value.
Actually, it was broken down. What did they say? Yeah, it showed me. I can't remember exactly, but yeah, I see what you're saying now, and I see I'm starting to see the question.
Okay. Yeah.
That's the way you.
Stop thinking about it, because the more you think about it, the further it'll try to run away from you. So,
yeah. No.
But anyway, just FYI, that section's there, so in case you need it, you might want to tie a note to that to Article 445, so that you just have a quick reference and you don't have to worry about trying to remember where it's at. But 445, excuse me, 450, not 445. 445 is generators. 450.3 on page 361. Just a note to yourself that feeders calculate under page 64. Now, you calculate a breaker or overcurrent device to protect those feeders or to protect the transformer under 450.3A or B, depending on the voltage rating, overall class voltage rating of the transformer. So it's 1,000 volts or more than 1,000 volts, and that's what the big table on page 361 is.
Right. I remember seeing that and actually looking at it.
Okay. And that one's got the stuff that's got the impedance rating on it and supervised location places and stuff like that. So again, though, it's just a table that's not really that much more complicated than the one right behind it, which is the under 1,000 volt transformer categories. So anyway.
Okay.
All right, so you had, did you have any fire pump questions asking you the size of breaker for a fire pump or?
Yes. There was a fire pump. What's that?
Is it like a 50 horsepower, 480 volt type deal? Design class B, used as a fire pump control, what size overcurrent device or blah, 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 inverse time circuit breaker?
I think it was. Yeah, I think it was a 50 horsepower fire pump.
Okay. Do you remember if they were asking you, was it based off of what value do you calculate it off of, or was it actually asking you the size of the breaker?
I think it said size the breaker.
Based off a number or actually size it? Probably was size of the breaker, if you're asking where I'm going with this, because for a while that question was just asking you what was the calculation based off of, what number would you use to start the math. But lately it seems like guys are saying that they're actually having to decide what size, inverse time circuit breaker they're actually going to use to protect it. And
I think that's what they were asking, was what size breaker.
so,
right?
Yep, but let's just say that you had that. If you had a 50 horsepower design class B fire pump motor, and you wanted to size an inverse time circuit breaker, what size breaker would you put that on there, and what are the steps, and where would you start?
Okay, so
the article that controls it, to kind of set you on your journey, is 695, just as a hint.
695 for the fire pump.
It's 695 dot.
Would be over current. No,
Yeah, it's on page 647. It's
125
695.4B1A. No, excuse me, B1. No, B2A1. Look on page 647.
Okay.
Bottom right-hand column where it says overcurrent device selection.
Right.
And under individual sources, number 1, it says overcurrent devices should be rated to carry indefinitely the sum of the locked rotor current. So that locked rotor current, that's the key that kind of sets the whole thing off.
Right.
And the indefinite part means that I've got to be able to carry whatever that sees value, that sees current for a locked rotor. That rotor binds down and doesn't move, and that amperage shoots up, and it's 10, 15 times what the nameplate rating would be.
Right.
So design class B, C, or D motors have a table that's on page 352 that you can use as a pre-calculated out LRC value.
Yeah, the fire, and that's where I went. I went to the 352 page.
Okay.
For fire pumps.
Okay. All right.
And of course, I went to the
430.251B.
What's that?
430.251B, is it?
Yes. And it was, but see, the answer didn't. I had it marked, but that didn't seem like it was the answer.
Right, like 363. Yeah. So if they're sizing a breaker, right, this is just your starting point. We've got to be able to carry that number right there for an indefinite time period, which means more than 3 hours. It's got to basically run until it starts fire on its own accord, and that's the last thing we want it to do. But melt down, or burn itself up, that's fine as long as it doesn't cause it more of a hazard. But the breaker sizing is off at 430.52. So if I'm sizing an overcurrent device, I'm still.
So do you take the 363 though? And size the breaker?
Yep, sizing 363 because that's what I've got to carry in that overcurrent device. I've got to carry 363 amps the same way I would carry just a regular FLC value.
Right.
Because it's a fire pump.
Okay.
I would take 250%. Let's say they're asking me for an inverse time circuit breaker, which is, I believe, what guys are saying they think it is. So,
it was.
Okay, I'd have to take a 250% value off of 430.52 on page 335.
Hold on. Say that one more time.
All right, so the breaker stuff is on page 335.
Right, but do we have to take the amps and multiply it by the percent, right?
That's right. So take 363 and multiply it times 2.5.
Right. Now we go back and we look at our actual.
So you're looking at a number that's 907.5, and there's a cutoff with breakers in 240.2C, I think is what it is. It tells you anything that's rated over 800 amps. We can't have the conductor has to be a bigger number than the breaker number. In other words, you have to round it down if you go past 800 amps. So in this case, since you're at 907, there's an 800 amp breaker, there's a 1,000 amp breaker, there's nothing in between.
Right.
So you can't round up once you go past 800. You have to round it down to 800, and I think that's the largest breaker size they've listed in the question anyway. So 800 amps would be pretty
so
confident. Right.
Where's that actually say that?
240 point. Well, the breaker size is under 240.6.
No, the point 12 says it.
Do what?
240.12 says that once you reach over.
No. It's 240.2, I believe.
Is that you? Me?
I don't know what that was. It sounded like it was me, but
Okay, overcurrent devices rated 8,000, round up. Hey, 800 or less. Okay, hold on. Round down. I remember you writing that, or actually telling us to write that. Okay. So I see it. So once you get to the 900, 907, we know that the only breaker.
yeah, the next
800 to 1,000, so it's an 800 amp breaker.
Yeah.
I'm pretty sure I missed that one.
Okay. I mean, look at that. That's one that takes a little bit of interpretation because there's nothing in the code book that tells you exactly how to do that. You kind of have to put these pieces together, know how they work, and have some experience with them for it to make any sense. But anyway.
Well, see, and I think I got the 363 and I got the 2.5, and I did the math. But after that,
Probably.
I must have just looked and said, "Where the hell's the answer?"
Okay.
Instead of rounding it down.
Okay, I got you. Yeah, if they're not, I think 800 amps is the largest answer that was available. At least that's what the guys are telling me. So I've not seen that one in person, so I couldn't really tell you for sure.
Yeah, but when I got 907 and I didn't see that as one of the top answers, I'm sure I said, well, I must have totally jacked this math up and I picked some
smaller,
non-realistic.
Yeah, well, you know, it's kind of scary to put an 800 amp breaker on a 50 horsepower motor. I mean, that's 363 amps is a big number as it is.
Right.
You're talking about 2.5 times that number in your size of the breaker, and you just in your mind you're thinking, there's just no way this is going to protect this motor, and
right.
It won't. It's the overloads that would protect it.
Right.
We'll do those in different systems.
Right. The overloads are going to shut out before the.
Yeah, it's not comfortable for an electrician to just throw 800 amps out on a breaker size like that. You know, I mean, it's just not what we do usually. So.
You know, the thing about the test is it took me back to the journeyman when I took it.
Did it?
In the aspect of, as I saw the questions, I didn't have a very, for some reason I thought, during the whole test, I was like, man, I'm finding the answers.
Yeah.
So I was actually, now how much time it was taking me to find it, I don't know, because I might have stayed a little long on some of the ones that I shouldn't have. But everything I felt comfortable, like I said, up to about 60-something questions, I was like, I'm all good. I mean, I'm there. I just got to finish these other ones, and I'll be there.
Yeah. Did you do that run through without your book open, honestly, the whole way through?
The first one, I did.
And how long did it take you? Do you remember, roughly?
I don't remember, and I don't know if that's what jacked me up, if I started daydreaming on the question. And
it may happen. I mean, 105 questions is a lot to read in an hour. I mean, and it's fast paced too. So
yeah, I think when I got to about 70, I remember having to almost slap myself and say, no, you got to keep going.
Yeah, it is.
Because I started stalling a little bit when I was looking at the question. I was thinking and trying to figure. But I remember having to speed myself up when I got to around 70 the first time through.
Okay, all right. How many of them did you feel like you knew in that first run through, just without worrying about without even looking them up?
I think around 35.
Well, that's strong. That's really good. Okay.
Well, I'm thinking realistically it was around 30 to 35.
Okay.
Because then from there I remember doing my lookups from about 30 to 65 to 70.
Okay.
And I looked back up, and then that's when I figured out I had 35 questions marked or something. And then I started working out through my stuff. And then I got so overwhelmed on those next 10 to 15, I lost the last 20.
Yeah, I hear you.
Right off the top.
So you remember, just to keep in mind, you're doing 3 separate piles of questions. You're doing ones that you know without a doubt.
Right.
100% good. And then there's a whole bunch more like you may be talking about that are ones that you have a good guess at, or they're not issue problems. I mean, you kind of know what they're asking, so you're not worried about it. Don't open the book now to deal with them, but they're ones that you know where they're at in the book, so they're not something to sweat over. mark a fake answer if you don't know the answer, and then flag them at the top of that mark button so that you kept them separate. Don't flag anything that you don't put an answer on, because you don't want to mix flag questions in your unanswered block. Right?
So there's a flag that you can flag it or mark. Are you talking about marked or flagged?
The mark button at the top.
Okay, marked button. And is there a way to distinguish, because I didn't know on this and I didn't want to start confusing myself.
Yeah.
Is there a way to mark it and answer it?
That's what I'm saying. You don't mark anything that you don't also answer. So every marked question should be an answered question. Now the difference is that you got a pile that are answered that you did not mark, and those are the ones that you felt like you knew, right? The ones that the block that you're not worried about, just to get them out of your hair, those are the ones that you just randomly pick an answer. It doesn't matter which one it is. You don't want to mark questions that don't have answers, because then they'll be mixed into your unanswered pile. And so you'll have some marked and some.
Towards the end of the question, towards the end of the test, I tried to get back to my marked. Something jacked me up, and it was showing me just my marked answered questions.
Right.
And I couldn't get back to my unanswered questions.
You got to click up there at the top where it says go to. So that right next to that mark.
But I went to go to marked questions. Well, what it did was it showed me what was marked left.
Yeah.
And it showed me the ones that I'd already went back through and answered, but they stayed marked.
Well,
so
you got to unmark them.
Unmark them?
Yeah, you have to unmark them. If you when you're in that group and you're dealing with one and you find an answer, then when you decide that's your answer, or you change your answer, whatever it is, the last step before you hit next is you got to unmark it, because if you don't, it'll stay in that.
I did start doing that because I saw that it jacked me up, and I was still getting marked answered questions in my deal, so I started unmarking them and then hitting next.
Yeah.
Unmark. The ones I did answer and to get them off.
Yep.
Get them off my screen, I went ahead and unmarked them. So, and that affected me towards the end too, because I had some that I was trying to get back to, and it took me probably 2 minutes out of those 10 to 15 that I had left.
Yeah.
To get back through it.
See, the way I'm not trying to beat a dead horse, because it's a minor detail, but when you're sitting in there, you got to realize there's only two ways to get better at this test, and one is studying and get more accurate, and the other one is time management, right? Mm-hmm. So the time management is critical for some guys. Some guys it's not, but the thing is that when I take a test like that professionally or just otherwise, I march through every one of those questions with a Codebook closed, and I'm methodic about doing that. If I know it, then it's an answer pile. If it's one that I know where it's at in the book, but I don't know the actual answer, I'm still moving that out of my way, because it's not one I'm worried about. I know that if I got 5 minutes left into the test, I know exactly where that question's at, what table it's at, whatever it is. Right. So I'm not sweating it, right? It's the ones that are that my problem pile, that if it's math or something I don't understand, or I just don't know where it's at in the Codebook, which there's a lot of those, right? So those, right. As soon as I realize it's something can't get traction on, it's next. So right. you may burn through 20 questions without answering any of them, and it blocks. Nothing happens. But you want to keep them separated like that, because when you get them at the end, you want to go to that unanswered block first, and right. Answer everything that's in that category, and so there's at least an answer on everything through the whole test, right?
Right. And
hopefully you'll get through with 45 minutes left of time to go back to the mark category as the last step. But while I'm doing the unanswered block, sometimes I'm marking those and answering those just to get them out of my unanswered category, because I still, like you said, you spend 3 minutes on a question the second time around, it's time to just let that one go.
Right.
You can't get married to them. You just got to. There's another one right around the corner. Come on, right. No.
What? Yeah.
Yeah. No. Okay. All right. Let's talk about the motor questions that you had. What do you remember about motor questions, just in general and then specific detail? But first and foremost, you had at least 8 questions that were motor calculations, or motor questions that would fall into the motor category. What kind of motor questions did you have?
If
sizing a branch circuit conductor for a single motor, maybe a couple of motors, feeders, taps, maybe.
I believe there was I know there was a feeder question, and then maybe a branch, as in What would be the? I think there was. I want to say there was a motor question that took us back. Besides the fire pump, there was one that was similar that talked about. What was it? The inverse time circuit.
Inverse time circuit breaker would be an overcurrent device, breaker or fuse or a branch circuit. Probably.
Branch circuit, maybe wire size.
Yeah. And probably breaker size. What I get from most guys is they get one or two questions that are wire, one or two questions that are breakers or a heater on the branch size, and then they'll get a feeder calculation. And
I remember a tap. There was a tap question too, but how would that be? How would that be stated?
The one that I see more often than not is a question where they give you three motors that are fed out of a gutter or something like that, and one of them is a 10 horsepower that's located 23 feet away from the gutter, and they're asking what size is that tap conductor for that 10 horsepower.
There was one similar to that, okay. But there was also I'm trying not to mix these up. I can't remember. There was one that stated, I guess, 4 motors, the different horsepowers.
Okay.
Something like a 25, a 15, a 10, or 2 10s and a 5 or something like that.
All right.
It was 5 motors. Because what they did is they had a high motor. They had like 2 middle of the road, same thing, like 2 10 horsepower motors, and then they maybe a 5.
Okay. That's
or 1 horsepower or something. It's something similar to that.
Okay. Were you sizing a feeder for that?
I think that was
was there a disconnect? Was it a question that had to do with the disconnecting means for multiple motors? Like a 7.5 horsepower and a 5 horsepower and then a 3 horse or 1 horsepower or something like that?
I think that might have been the disconnecting means on that one.
Okay, so but not this question you're talking about here. Even worse. Here's one I know that one that he's got written on those answer sheet those pages that you have. There's a question on there that's got a 7.5 horsepower, a 5 horsepower, and like a 2 or 3 horsepower motor, and they're asking the size of disconnecting means for the whole group as one device.
Hold on, let me see, because that might have been one that I highlighted.
And I'll tell you that it's been on every Masters recently, and it's one that I had never heard of before, maybe 6 months ago. So it was one that I think they're kind of floating on the
that was towards the end, right? I think.
Yeah, I think so. I don't remember off the top of my head the exact sizes, but it's listed on that page because he had them listed down there with even the correct answer block on that one in particular.
The 39.
The article number is 430.1. Let's see, 430. I'm right on top of it. 1. It's 430.110C 2, really kind of.
Oh yeah.
You see it?
Yeah, but I don't remember seeing about a squirrel cage.
The squirrel cage is just a motor type that's.
Yeah. Could they have used the same wording without?
Yeah, he might have gotten the squirrel cage mixed up with another question, quite frank. But wound rotor, squirrel cage, wound rotor, squirrel cage, and what's the other? Unity type power factor. Now, unity type power factor motors are different. Those have their own little section on the table. But I have heard somebody say recently that they had a unity power factor motor question or motor calculation because they had to use a different part of it. But on the answer to this thing, if you look on page 345 of your code book, what size motors do you have listed there? Like a 7.5?
7.5, 5, and 3.
Okay. And they're all, does it say it's 208 volt or?
208 volt.
Okay. So we've got a value of those 3 motors. Let's look at them real quick. So 208 volt 3-phase for the 7.5 is 24.2 amps. For the 5 horsepower, we're looking at 5 is a 16.7 and the 3 is a 10.6. And so this section tells you that you got to take 115% of the combined total FLC values of those motors. So it's unlike your feeder calculations with wire or breaker sizing for overcurrent devices for feeders, where you just take the largest motor and then the rest of them at some other value. This one we're taking the whole shoot match. So we'll just take the 24.2 plus the 16.7 plus the, oops, my calculator rounded that up.
And the reason that we're doing that is because it's the rated disconnect, right?
Right, it's disconnect rating. That's right. So
right.
That's under that article says that the ampere rating of the disconnect means shall not be less than 115 of the sum of all currents at full load condition determined in accordance with 430.110C1. So
right.
the 4.2 plus 16.7 plus 10.6 gives us a 51.5 combined total, and then that would be 115% of that number times 1.15, and that gives you 59.225, so 59.23. It would be the minimum rating for that disconnect means. Now, disconnect means, you know, those are standard sizes on those, so you'd have to round that up to 60 amp disconnecting.
Right.
That's
do you think they would have rounded it?
I think they're asking for that exact number. I think it's 50.
Right. That's not going to be a roundup. Now, if they ask for what size fuse or breaker,
that's a whole different animal.
Then you could round that up to 60 and look for that, right?
No, that's a whole different animal. It's not even close to the same. This is a non-fused disconnecting means it just cuts it away from power. It doesn't have any overcurrent protection device, or it's not designed to pop. You know,
right. It's not designed to protect it.
Nope. It's just a shutoff.
Oh shit. Okay.
Now sizing an overcurrent device for feeders, where we're sizing a breaker for groups of motors, that's under 430.62, and it's kind of a crazy math. But I would almost guarantee you had one question where you had to size a breaker for a group of motors.
I've
oversimplified it, so I can tell you an easy way to do it. It's just that you're going to have to take my word on it and not try to read it out of this code book, because it's not going to make any sense to you. Trust me. But I'll tell you confidently how they calculate them and what to do with them. So,
well, how would that be? So,
hold on one second. I got to unplug my air compressor before my neighbors get mad at me. Hold on.
Oh, shit. 40 point.
I give them enough cause to be mad at me all the time anyway. I don't need to have my air compressor that I've got outside because I didn't want it bothering us. Keep going on. It's what is it, 8 o'clock at night or whatever it is.
Right.
What time it is? Do I really want to know what time it is? What time is it?
9:10.
Woo! All right, let's wrap it up. I'm just kidding.
Yeah.
I'm just kidding.
Hey, no, you're right. There was a question on this.
So let me just give you a couple sample motor sizes, and I'm not saying that I even have any idea that this is even close to what might be on there, but I think the steps are pretty cut and dry, and they're not hard to kind of wrap your mind around them. So basically, here's the deal: when we're doing a single motor by itself, just one motor with whatever that last overcurrent device is, we're going to round that sucker down because of the way it's written in 430.52. So let's say that I had a single motor that was sized as a 25 horsepower 208 volt motor, right?
Right.
2 horsepower. So the FLC value of that motor is where you're going to start. So a 25 horsepower 208 volt 3-phase motor is what FLC value? I don't have my book open in front of me.
25.
How much? 25 horsepower 3-phase 208 volt.
20 horsepower,
25.
25.
Yeah.
74.8.
All right, so 74.8, and that's, once you get past that startup and settles into what it's running, that's what we kind of expect that to run.
Right.
All right, so 74.8 amps. Now on page 335, your breakers and fuses are on that table. It's on the upper right-hand corner of the page there. 430.52 is the table number.
Right.
So depending on the type of overcurrent device they ask you for, let's call it an inverse time circuit breaker. So
Okay.
that's the last column. The top two rows are the same numbers, 250%.
Right.
Take 2.5 of that 74.8, and then because of the way that the rules on the left-hand side of the page, kind of on the down there under 430.52C1, the way they've got it as an exception, and we would, in the field we'd round it up, but on the test you're going to round it down. So we would take 74.8
Times 2.5.
and that gives us a subtotal of 187.
7.
They don't make a breaker, and don't let them catch you slipping by picking a 187 as an answer either, because you're going to have to make a decision to round up or down. You're going to round that down to 175.
Okay, 175.
That's the next standard size breaker, below 187.
Okay, so that one we would still, okay. All right.
As an individual motor, just one motor, one breaker.
Right.
That's it, yeah. All right, now let's add this same motor to two other motors. That's a 10 horsepower and a 15 horsepower. So if we had a 25, a 15, and a 10.
30.8. Hold on. A 15 and a 10?
Uh-huh.
So 46.2 plus a 30.8.
All right, so now I've got three motors. We're talking about, a tap off of a set of feeders. And so we're talking about the breaker that's protecting that set of feeders in the very, very front of the circuit, right?
Right.
So when I've got a situation like that, the rules shift from being under .52 to being under .62, and the permissions there are to take the biggest permissible breaker size for the largest motor that's available to you under .52. So we would do the same math, except when we get to 187 amps, we would round that one up to the next larger size breaker as kind of a mid-step. So in other words, I'm still going to take that 25 horsepower motor.
Right.
Still going to take 250% against it. I'm still going to come up with 187, but instead of rounding down as an individual motor, the rules under .62 tell you to take the maximum permitted size, and that would include the exception in that case. So you round that up to a 200 amp breaker as a overcurrent device for the feeder, and then you turn around and you tack on to that breaker size the other FLC motor values of the other motors in the group. So you just simply add 46.2 and 30.8 to that 200 amp breaker. The hardest thing in this whole thing to remember is that you're calculating on your calculator a value that's your capacity used to size the breaker, right?
Right.
You've got to remember to delete that off your calculator and put that breaker size, because you're artificially picking a breaker size off that list, and then that's the number you're adding those other two FLC values to that motor. And then you ultimately have to round that down anyway when it's all said and done. So step one, take the biggest motor, round up. Step two, add the other FLC values to it, round down.
Right. Okay.
It comes to like 276.
Right.
And so that would be a 250 amp overcurrent device, because we'd have to ultimately round it down when it's all said and done.
Right.
Okay.
Okay.
What size feeder would you have for that group of motors? He would have to ask that. What size?
Same. Like I'm in class.
You are kind of.
What size feeder?
Feeders are under 430.24, page 3.
430.24.
24. It's almost exactly what you just did with the breaker size for the meter, but except we're using a different value for the multiplier.
You said 430. What? 24?
24. It's on the right-hand column, middle of the page 330.
Right. So 125% of the full load current rating of the highest rated motor. So instead of taking the
74.8.
right, 74.8 times 1.25.
Yep.
And then the sum of the, so basically the same thing as what we just did with the, okay, so 74.8 times 1.25.
93.5.
93.5.
And then you add 46.
Add the 46.2 and the 30.8.
That's right. Now, the only other major difference here is that with the breaker, we were rounded down with the wire size. We have to carry that as a minimum value, so we need a wire that's got at least that value, if not more.
You're right. That, okay. 46.
And what page do you have the wire capacity stuff on?
I don't know.
Page 161.
Wire capacity. That's
We use a 75-degree column for motors given to us under 110.20 or 110.14 C4.
oh, good. I'm glad we went here because there was a question that I think I remember that threw me for a loop.
Why don't you just let me go take your test for you tomorrow?
I would love that. Go ahead.
Yeah, I'd love it. What are you talking about?
You probably remember a lot more.
I guarantee you I would walk out with total recall. I'm not kidding. I would know most of that test by the time I walked out of the test center, but only because I know most of these questions, you know, sort of kind of from the backside. So
right.
It's not really memorizing the whole test. It's just clarifying the ones I already memorized. Does that make sense?
Right. Yeah. No, I wish you could, because then you could actually rewrite all this stuff. All right, I don't know where I'm at.
Page 161. Size and the feeder for that motor. 300 and was it 30? Well, 199.7 amps. Is that what it came out to be?
170.5. Does that not sound right?
Oh, let me go back up. I hit the button and it came out 74.8 times 1.8
times 1.25 plus 46.2 and 30.8.
170.5, yes, sir.
Okay, and then we're going to go to the
75-degree column.
Right.
175.
175, which is 2 knot.
2 knot? 2 knot or 3 knot?
For 175?
Yes, 2 knot.
Mm-hmm.
I was laughing at the way you said 2 knot instead of, well, this is what it came across.
What?
Nothing.
Oh. So,
I'll tell you how to speed it, and the breaker for it, for that matter. So you'd have a 250 amp breaker on a wire rated for 175 amps. Just the way it goes, because we're not using that breaker for the over load protection. So that breaker's purpose is just for that, you know, that inrush current if there's a ground fault or short circuit, and if that happens, it's way more than 250 amps. So
right.
We're talking thousands of amps if that happens. So it'll take care of it. The heaters in a separate form of overloads at the end of the wire, branch wire, is going to be what protects that feeder from the overload device or overload hazards.
Right.
Okay. What else do you remember about motor questions? Nothing. That probably pretty good. Did you have any kind of heater questions or overload questions? That's me, I guess.
Maybe it was a single phase motor.
Yeah, maybe. If you look at DC motors on what page are you on?
349.
Okay, 349. All right.
Because I don't remember coming. I remember looking at my DC on the column where we wrote it in, but I think I remember more on the single phase column.
Okay. Well, if you look on page 335, if you size in a breaker for one, it's at the bottom of that table instead at the top.
Say what?
On page 335.
Right.
If you're sizing a breaker for a DC motor, it's the very last row there.
Right.
So it's got its own numbers, own category would be the big difference there for DC motors versus a AC motor when it comes to the overcurrent device. It's 250% on a, like even on instantaneous trip, which is that's usually 800% of an
Right.
AC motor. So.
And then 150 on the others. Okay.
Yep. Same rules apply. Just use the FLA values on page 349 against that number, those numbers there, and then round down if they don't give you exceptions, so on and so forth. It'd be the same deal. Now, overloads for DC motors, for AC moters that are for air conditioners, where the DC or AC is not really the relevant part. The fact that it's a hermetic refrigerant type compressor motor, those are under 440, and those are 140%. There's just one number, and that's just all you got to remember.
How much? What is it?
140% for the overloads for air conditioner. And then for the breakers, it's 175 and 225. And I just put those on page 3, but really page 350 or 351, somewhere in that space down there. I'd probably just put them on that page 350 and just put a note. AC motors for the breakers and fuses would be 175 or 225 if you have issues with the startup current.
225 on startup?
Yep. If you got startup problems, 225. And both those are max values. And then for the heaters, it's 140.
So to size the heaters, it's 140.
Yes, sir.
I had all my notes in the book. She asked him, are these okay to have? And he said yes. So
Who's he?
the guy, the tester. There was a lady there that was checking, and he was the proctor or whatever.
Yeah. Was he a dick?
No, he wasn't bad. He was actually decent. I took it the first one at not Park 10, but the other one. I don't remember the name. So it's that one over. I don't think it's real far from it.
They're pretty close, but
Yeah, they're pretty close.
The Park 10 one is the one they say they don't care.
Yeah, that's the one I'm going to tomorrow. The other one,
Yeah.
but the other one wasn't that bad either. He was decent. I mean,
Saturday, if you took him on Saturday, usually
he
they don't
let
care.
me come in because I got there at like 9.
Yeah.
I sat in the truck and went over everything, and then I went in because I thought we were checking in at 10:30 for 11 o'clock test, but it was actually 11 for 11:30 o'clock. So he said, if you're ready to take it, you can come on back in and start.
Yeah.
He said, you're the only one here. So he was cool. There wasn't any big deal with him.
I'll tell you, and not that I mean, it's just something that's there for you if you want, but I don't have a class tomorrow. So especially at Park 10, just make sure your phone's off and just keep it in your pocket. If they ask you if you got one, just say, no, I left it in the truck. And
yeah.
I mean, if worst comes to worst, if you get stuck, I'd rather answer a couple of questions than have you go through this whole thing again. But I mean, I'll be there for you if you need me. Just say, just don't flush the toilet, and that way I don't have to worry about my conscience bothering me, you know.
Right. No, I will.
Usually I make that offer, and sometimes guys will take me up on it, but 9 times out of 10 they don't need it. They end up making an 85 or 86. So it's just the confidence in knowing that you got somebody there that will help you if you get down to it. You know what I'm saying? So,
Right.
I mean, it's anyway.
Yeah. So if we go back to the 45 degree, because that one had me jacked up, because that wasn't ambient, but
Was it operating temperature?
I want to say it was back on a wire calculation. Does that sound right?
Yeah, I mean, it'd be an ambient temperature like 44 degrees Celsius or 45 Celsius.
It was 45 degrees Celsius.
Okay. Yeah, if you look on page 158.
And now, I think I remember you going over this. Damn it. Yeah.
It's the Celsius are on the first part of the table, and the Fahrenheit's at the last column there. But I mean, it's just the multiplier you'd use to offset that temperature rating.
Ah, shit. I remember now. Yeah. That had me jacked up. Okay, because I got to I found all my stuff, and I don't remember if that's the one that we added up the different wires or.
No, don't sweat it. Just let it come to you, and then in the morning, when it comes to you at 2 o'clock in the morning, don't call me at 2 o'clock, but when you call me in the morning before you go to the test, I'll.
I remember it was it had to be the thermal rating on the wire size of particular wire. Would that be how the question was rated?
It might be. I mean, if you're looking at derating stuff for ambient temperature, the class or the temperature rating of the conductor overall is where you start, which is the 75 or 60 or 95 90 degree value. But 44 degrees would just be used as, or 45, whatever the Celsius you had there, that would just be used to offset the ampacity of that conductor at given 86 degrees Fahrenheit, which is what that table value on page 161 is based off of. 86 degrees Fahrenheit, I don't know what that translates into Celsius. I want to say it's
30 degrees.
Okay, so 30 degrees.
Is that where you take the left column and find being that they said 45?
Yep. Yeah. So you would start on the left-hand column.
Start on the left column and go to
You'd want to use the same column for the temperature class rating that you're pulling the ampacity value.
Pull from the wire?
Yep.
Okay.
So if you use the 75 degree column, you'd use 75 degree column there to pick the multiplier against that 75 degree value on page 161.
Okay. And what if I took the? Okay. No, I see it now. Yeah, because once I got to once I saw that 45, I forgot about this table that we talked about in class. But
okay,
that's
45 is a number that I could see where that would confuse guys, because 90 is the value that we have for that last column, and so guys will get that confused with the ambient temperature, and so they almost always give ambient temperature in Fahrenheit, and that's more fair because at least you kind of have a different unit to compartmentalize them in your mind. But
right.
if they start throwing out Celsius on everything, it can kind of get confusing.
I remember you went over the Celsius part, and when we were talking about the wire and how you can only.
But look on page 333 real quick, or 332, 333, and look at your service factors and your ambient temperature value, or excuse me, your maximum operating temperature for motors under your heaters.
So where?
Look on page 332.
Okay.
430.32A1. There's 3 rows there. Look at the second row where it says maximum operating temperature of 40 degrees Celsius. So 45 degrees Celsius is a motor calculator. A motor question would mean something significant to you when it comes to the heaters. Page 332 and 333.
Okay, I'm there. I'm just not.
So do you see the 3 rows on the left that have service factor 1.15 or greater is 125%?
No. Why am I not seeing this?
You go what?
I'm just not seeing this. What?
On page 3, you're on page 330.
I'm on page 332.
Okay. 430.32A1 is the article.
Not A1. Overload devices.
Yep. You got 3 rows there.
Okay. Sorry. Got it. Okay. Motor service marked service factor 115 or greater.
Look at that next row.
Okay. Motors with the marked temperature rise 40 degrees Celsius or less. And
that's it right there. So if they gave you a motor that had a marked temperature rise of 45 degrees Celsius, that does not fall in that category and would be all of the motors at 115%.
Right.
Size overloads. So I'm not saying that that's what it was. I'm just saying that's the other place where some question that 45 degrees Celsius would matter to me, and that would be right there.
Right. Okay, I got what you're saying. I think it goes back to the the rating of the wire is where that question went. But
Okay. Well, in that case, where we were at just a minute ago would be more appropriate. Yeah.
okay.
Just wanted to make sure I'm covering your bases.
Oh yeah, no. Because I remember us touching on the 90, the 75, and the 60, and when we use 60 versus the 90 and the 75. But when I saw that 45, it threw me for a loop, and I was like, "Oh crap!" It's like everything just shut the door, and I
yeah. Man, I tell you, I'm about to fall asleep on you. I don't.
that's fine.
There you go.
No, I appreciate you going back over some of this stuff with me.
Any other questions that you can remember that just you just dying to know how to answer though?
No.
Okay.
I wouldn't be able to tell you the question, so.
Well, no, if you just, I mean, it's always good for me to kind of get, some feedback. It's not always, sometimes it's like what you got where you get scattered ideas or sometimes questions kind of meld together.
Right.
Sometimes I have to hear from them like 5 or 6 different guys before I start to kind of zone in on what the question actually is. But that's just part of it. I mean, it's
well, hopefully I'm not so amped up tomorrow and I can actually memorize, or not memorize, but actually put together some thoughts on what the questions were and everything, so I can give you some better feedback.
Yeah, but like I said, I'm more worried about you getting through this thing than I'm worried about that. So, but
me too. I know some of this stuff helped me, so I want to pass that on to the next person.
Absolutely, that's how it works. Because I mean, if it honestly, I mean, I'm only as good as the information that I can get from you guys. So I mean, right. That's the problem with stuff like this is that if they change the test drastically on us, it takes a year to get back in track with it. So
now I got a question for you.
Okay.
After talking to everybody that's taken and went back to retake it, how serious do they change the questions up? I mean, can I look at a 50% change on me?
Yeah, it depends on the guy. I mean, sometimes a week difference makes all the difference in the world. Sometimes it's 2 months and it's the same block of questions. But I feel like lately that because the overall pass rate went from like 17% to like 40%. So I think what happened was they fixed the number of general questions that they ask over the board down to a couple hundred questions, which is kind of what that stuff that you're looking at represents.
Right.
So I feel like you'll probably have 30 questions that you've been seen before. You kind of know what they're at. So the second time around, you'll have a block of time that you didn't have the first time, I think.
Okay.
But don't quote me on that because if you,
I know. I'm just trying to figure out realistic how many more I have to look up versus what I looked up this last time, because
I would leave
I know I'll gain some time on that.
Yeah, and you'll gain some more. I mean, not only the study stuff afterwards, but just the experience of it before. Now when you're looking at those questions, some of them stuck out to you, so you probably focused on those more than you did originally. So, I mean, I would not be surprised to see you make an 85 tomorrow, to be honest, because I mean that's usually what happens with guys that take it that first time, and then that it all kind of gels in their mind after that, and they kind of have a little bit of time to kind of assimilate it all and sort it out. But. I wouldn't worry about it. What I do tonight is I'd just leave it alone. I wouldn't even, as soon as we get off this deal, I'd just go to bed, because sticking it into your head anymore right now is just going to keep pushing out the other side. So, get up, have a cup of coffee in the morning, study just a little bit in the morning, and then leave it alone again, and don't even look at it for like the last hour or so before you go in that test center. And then remember, when you first sit down, that little pre-test stuff about the flags and the stripes of the flag doesn't matter. Just let it alone. Just go through your prints at that point. Kind of take that scratch piece of paper and maybe pre-fill it out. Just kind of get your wits about you and take a deep breath. And then when you're ready, you start the test on your dime, and so you get a little time to ground yourself and kind of get situated.
Okay.
All right.
Sounds good.
Well, man, I wish you the best of luck, and I'll be waiting to hear from you tomorrow. I'll keep my phone on, and then if I don't hear from you about 11 or 12 or 1 o'clock, then I'll wait until 3 or whenever you're done.
All right.
All right, sir.
I appreciate it.
You bet. Have a good evening.
You too. Bye.
Stop recording.